Greetings, everyone. Welcome. This is Mark Mullins from Fluke Networks speaking to you from the Fluke Networks webcast studio here in Everett, Washington, and I'd like to wish everyone a good day. Don't know what time it is where you are, but it could be just about anywhere because we've got a lot of participants from all over the world who are here to talk about today's subject. Just to let you know, you should all be muted right now so we won't hear any dogs barking or Amazon delivery doorbells or people slurping their coffee, so that should make for a nice presentation today. Let's see, I'm wondering if there are any hearing problems. I thought I'd just make one more check and make sure to see if anybody can hear me. So if you can send a message via the chat window that if you can hear me, that would be great, because I think we should be all right. Okay, I'm getting indications the sound is okay, so that's good. Thanks very much, everybody. I did get one call that I couldn't hear anything, but maybe that was because we haven't started yet. Anyway, thanks for coming to today's event. We're going to cover the basics of cabling and cable testing. It should be interesting and fun. If you're looking for the really advanced class, this probably isn't it. This is just learning about the basics of cabling and cable testing so that you can troubleshoot and maintain. We've got more advanced classes, for example, our CCCT, which is our Cabling Certification Test Technician course, which spends 2 days covering many of the same topics in a lot more depth. This is just a getting started class, so let's get started. So one of the questions people might wonder about is, why do I need to test cable? You know, it pretty much works if I hook it up, right? It shouldn't really be a big problem. Well, this is a post we got on Facebook to our Fluke Networks page from a gentleman. And he said, you know, which termination of these is in the proper manner? And if you look at the two, the one on the right and the left, they don't look that much different. There's a little less jacket. The jacket's been pulled back a little bit on the left-hand side as compared to the right. But I showed this to a number of experts in our company who are, you know, they're on the TIA and IEEE committees. They should know good cabling when they see it. And their answer was, yeah, they both look pretty good, but I probably want to test them to make sure they're good. And that's the reason, of course, is that you can't just tell by looking at a cable whether or not it's good. The one on the left shows a little bit better workmanship, but they both might work fine. One of the things I don't know is that Cat 5 or Cat 6A. Don't really know what kind of cabling that is, but with a cable tester, I could figure all that out and know whether or not it's going to work. The other option, of course, is to just plug it in and pray that it works. Plug and pray, as they like to call it. So that's why we want to test. So what will we talk about today? Well, we already talked about why you might want to test. Then I'm going to cover a little bit about, it's a pretty advanced topic. I took some electrical engineering, and this is actually easier than any of the electrical engineering classes I took. I call it transmission line theory for dummies, and it was explained to me in some very simple terms by some very smart people a few years back, and I think it'll help you understand exactly how this twisted pair cabling works. We'll then talk about some different measurements, and then two different kinds of standards, which is often confusing to people. There are cabling standards, network standards. What are the differences and why should you care? Then I'll talk about what can go wrong in twisted pair cabling, what are the most common problems. I'll talk about testers and how do you pick the right tester for the job you're trying to do. Then we'll cover some Q&A, and then I'll leave the presentation and give you access to some resources, which if you want to learn more about cable testing, you can do. So let's talk about cable. Let's talk about transmission line theory. So the way cabling works, in most instances, this is a simple example. This is, say, a good example for 10 base T. You've got two pairs. So the gray line indicates one wire and the black line represents another. You've got a transmit pair and a receive pair. And obviously, the transmit pair at one end is the receive pair for the other end. So your computer is on the left and, say, the switch is on the right. And you send the signal down those cables, and they get received at the other end. Another signal comes back the other way. It's all great. Everything works really well. Now, the problem is in electrical theory, you'll hear about this thing called crosstalk. And what that means is if I induce a signal on one wire, it will create a magnetic field. And a magnetic field can induce a signal on another wire. So what happens is I send my little pulse, say, or my little wave, which maybe represents a 1 or a 0, down the transmit pair, it generates this magnetic field, which then gets picked up by the other wire and comes back in on another pair. Now the signal's smaller, of course, but as signals travel down the wire, they get a lot smaller. So the transmit signal could be 1,000 times bigger than the receive signal. So even a little bit of crosstalk can look like the guy at the other end is trying to talk to you. Of course, for those of you who are maybe over, I don't know, over 40, you might recall being on phone calls some days where you could hear like this faint conversation in the background of another person's phone call. It kind of screws you up. That's where the whole term and the name crosstalk came from. And for computer communications, it can really be devastating because every time you start to talk, you have to stop and listen, but it's just yourself talking, so every time you talk, you have to stop. What's worst about these kinds of problems is they can kind of be intermittent. For example, they could be a problem that where your cable works great at 10 megabits per second, but if you crank up the speed, you go out and get some new hardware, you go to 100 or to a gig, it won't work anymore because everything gets more sensitive as the speeds get higher. So crosstalk is probably the most problematic issue in transmission line theory and in cabling. So how do you deal with it? Well, the smart engineers came up with this idea. They call it differential signaling. So what you do is you send a positive pulse down one wire and an exact copy but a negative pulse down the other wire. So what happens is you get two magnetic fields, but they're equal and opposite, and they cancel each other out. But not entirely, because if you look at my picture here, you'll see that the black wire is a little closer to the gray wire below it, and so it picks up a little bit stronger signal from the black wire, the bottom cable, than it would from the gray wire. And that means you're still going to get some crosstalk there. Even though it's been greatly reduced, there's still some. So how do we get rid of that? And this is where it's like, really, that's how they do it? They just twist the cable. So what that does is that means that sometimes the black one of the transmit pair is closer to the black one of the receive pair, but sometimes it's closer to the gray one, and over the distance of the cable, it all cancels out, and you get very, very little crosstalk. And you'll notice, if you do this, if you look at this picture, though, you'll notice, hey, the one at the top is twisted slightly different than the one at the bottom. Well, and in fact, that's intentional. If you look at twisted pair cabling, each pair has a slightly different twist rate so that the black isn't always closer to the other black, or the gray isn't always closer to the other gray. And so they will tend to cancel out and over the course of the cable. That's really how they did it. And you think, well, that's really not that complicated, is it? And it's not. It's a pretty simple theory. In fact, if you go and look at cable, if you take it out of the jacket, a typical 4-pair twisted pair cable, you can even see in this picture here that the twist rates are slightly different. The blue pair is twisted a little more tightly than the orange pair, and so on. You can see there's a slightly different twist rate on each one. One way you'll see that is when you're using a tester, you'll notice even a very accurate tester will report different lengths for the cable. This is an example of one here. This cable is only 20 meters long, and yet you can see there's more than a meter's worth of difference. That's just because the tighter you twist the cable, the more length there is in it, electrical length. So the cable on the outside may be exactly 20 meters long. You'll get these different measurements, and it's not a problem with the tester. It's just the fact that the twisting is different between the pairs. Now, with cabling, the twisting really gets rid of almost all the crosstalk. It's really an amazing mathematical certainty that you get rid of most of the crosstalk. But you still get crosstalk in cables. You get a little bit during the cable. The bigger problem is in the connectors. And if you look at this image on the left, you'll see why that is. Notice those cables, they're not twisted anymore, right? When they come out of the jacket and they go into that plug, they have to get untwisted for a little bit, and even that short little distance, which is, much less than an inch, a centimeter or two, it's still, they're in pairs, and there's going to be crosstalk because they're not twisted anymore. The same thing can happen on a jack, although you can see the person who put the jack together on the right there did a pretty good job of keeping them twisted all the way up to the point where they plug in. But then if you open that jack up, you'd see the wires inside. Once again, the pins, they're going to be parallel to each other. They're not twisted anymore. So connectors are where most of the crosstalk comes from. In fact, that's where a lot of the engineering work has to be done to make really high performance cabling systems. So let's talk a little bit about the different measurements now that you understand everything there is to know about cabling. The measurements, we're going to start with the simplest one, which is wire mapping. And wire mapping just determines are the wires connected to the right pins on the cable or on the jack or the plug, whatever. And the upper left corner shows the correct way to do it. So every pin starts at one side, goes to the other on the right one. Now, here's a few of the problems you can have. You can have it open, which you can see there, one of the pins isn't quite connected. That's probably the most common wire map problem. You can also have a short. That can happen if a cable gets pinched in the wall or if somebody does a really bad job of terminating it at the end. You can have reverse pairs. That's not that hard to do either, where you hook them up wrong. Crossed pairs is a little less common of a problem. However, it can be actually very common if somebody is using a crossover cable. Sometimes you'll have a cable that's designed to swap the transmit and receive pairs. Most electronics nowadays don't care about that. They'll fix it themselves, but not always. And sometimes that can be a real problem. And in fact, what will happen is sometimes people will wire up in the walls. They'll do things like cross the pairs to make things work better. Sometimes they'll also use separate pairs for the phone and other things, which none of this is standard. And while it's fine if the people who put it together are still working there, when somebody new comes along, they install something, it doesn't work, you don't know why. The last one I want to talk about is split pairs. And in a split pair, what you see happen is if you look at the ends, everything's connected to where it should be. In other words, if I follow the, say that green one all the way through to the other end, even though it goes through the brown cable, it comes out to the green end on the other side. You think, well, that should be okay. That's not okay, because what will happen is the transmit and receive pairs will be twisted together, say, for example, the positive transmit and receive pairs instead of the positive and negative. What happens is instead of the signals canceling out, as we showed in the earlier example, they'll actually be constantly together all along the length of the cable. The crosstalk will be tremendous, much more than if they were just straight, and the cable won't work. And once again, as I pointed out, sometimes these kinds of things will work for a while, or sometimes they'll have a lot of errors. Ethernet is very, very forgiving, so you can have that kind of bad cabling, and it will continue to work most of the time and some of the time, but then you get these intermittent problems that can take you hours to figure out. That's another reason why you should test. Now let's look at some other measurements. We talked about crosstalk, and actually crosstalk can be measured. It's a fairly simple measurement. You kind of see what is going on here. The near-end crosstalk is just the ratio of the signal I put in on one pair divided by the signal I get out on the other pair. And it's expressed in dB. So you'll see like 40 dB of crosstalk or 60 dB of near-end crosstalk. Actually, the bigger the number, the better. Now, sometimes you'll see crosstalk expressed with a negative number. All that means is they just flip the next over the in, and they make it a negative number. And then the larger the negative number, the better. So basically, you always want the bigger number. 40 dB is better than 30 dB. Minus 40 dB is better than minus 30 dB. So just look at the absolute number, the bigger the better. And there are 6 different crosstalk measurements that are made. There's near-end crosstalk, far-end crosstalk. There's a ratio of crosstalk to the actual signal, and so on and so forth. Also, you have to measure the crosstalk on 6 different places between pairs 1 and 2 and 3 and 6, between 1 and 2 and 4 and 5, between 1 and 2 and 7 and 8. So you actually end up with lots of different crosstalk measurements in a cable. It's a lot to keep track of. Good reason to use a tester. Another measurement that is important is delay and skew. Delay is just the time it takes a signal to travel the length of the cable. Signals travel at about 70% of the speed of light. And so the cable, if you know that propagation rate in the cable, also called the nominal velocity of propagation, you can figure out the actual length of the cable as well. But remember, each pair will be slightly different. A measurement that's very important, especially for high-speed networks like 10G base T and even gigabit Ethernet, is delay skew, and that's the difference between the pairs. You might think, well, I'll just twist one of them a lot and one of them not very much. The problem is you'll end up with a pretty big delay, and so the signal doesn't all get to the far end at the same time, and that can really screw up the electronics. So there actually are standards that say what the delay needs to be and what the difference in the delay between the pairs need to be. Another measurement you don't hear about a lot is resistance measurement, and until recently it wasn't really that important. There's actually 3 different measurement resistance. There's the loop resistance, which is what I'm showing you in the picture there. So what's the, if I put in a signal on one end and go all the way down and come back on that same pair, what's the resistance in that? And it's very low. It's like an ohm, in the range of an ohm. There's also the resistance unbalance between the pairs. Do the pairs all have approximately the same resistance? Are they close together or not? And then there's resistance unbalance within a pair. In other words, in the top example, what's the resistance of the blue and white wire versus just the blue wire? Now, why does anybody care about this? It's not really a significant issue in data communications, but it is a very significant issue with high-power PoE systems. There are PoE systems now that can deliver 60 watts over twisted pair cabling, and if the resistance is not balanced properly between the pairs, you can end up with the cable heating up, and then as the cable heats up, the resistance increases, the power can't make it through the far end, and you get intermittent problems as well. So this is a new measurement. That's not really new. Resistance has been around for hundreds of years, but in terms of cabling, it's now getting a bigger importance as these new high-power PoE networks are starting to be deployed. You can run an access point, a camera, and now even flat panel TVs off power over Ethernet. So if you're doing that, make sure you're measuring the resistance and the resistance unbalance. Make sure your tester's checking that out. It's very important. Otherwise, you're going to get intermittent performance and not know why. Now, there are a lot of other measurements. I'm not going to talk about them all here because they are not as common, and many of them are related. In fact, all of the ones that say near-end crosstalk, ACR-N, ACR-F, all of those are basically different crosstalk measurements. I mentioned there are 6 different types of crosstalk measurements, and those are just basically variants of a crosstalk measurement. Insertion loss and return loss relate to how much does the signal degrade as it travels over the distance. And then there's a bunch of other ones, length and propagation delay and skew we talked about, resistance we talked about, Wiremap we talked about. Transverse conversion loss is one for the more advanced class. We'll skip over that right now. Just make sure your tester can check it and make sure it's okay. So those are all the measurements we got. 2 other things to be aware of is when you're measuring the performance of a cable, there's a number of different configurations, and the 2 most common I'm going to talk about, the first one being the channel. The channel is everything from the beginning of the patch cord where it plugs into, say, the back of someone's computer, all the way to where it plugs into the switch at the far end. So as you can see with the green there, it says you begin the measurement right before where the patch cord plugs into the piece of equipment, and you end the measurement at the far end. This includes all the patch cords, all the stuff in the wall. If you've got patch panels and different sorts of connection points, it's everything from end to end. So it's basically, if you think about it, that's what the IEEE, when they define a network standard, worries about. It's what a network owner, if I'm troubleshooting a network, that's what I worry about, everything from end to end, right? I can't just worry about part of it, got to worry about the whole thing. The permanent link, the easiest way to think about that is that's the stuff in the wall. It generally starts at the jack in the wall, goes all the way back to some patch panel where then you would plug into an instrument. And this is what contractors and building owners worry about. Now, one of the things, if you were very attentive, you might have noticed the distances for permanent links are different than the distances for channels. So you can see a permanent link here, 90 meters. I go back to the channel, it's 100 meters. For most limits, most TIA limits for testing, say for Cat5e, the channel is limited to 100 meters. The permanent link is limited to 90 meters. What's the difference? You got 10 meters for patch cords. All right, speaking of different kinds of standards, let's talk about the different standards. There's cabling standards, which are defined in North America by the Telecommunications Industry Association. In Europe and other parts of the world, they're defined by the International Standards Organization. Those organizations work together pretty closely and harmonize them, although they have different names for the standards. We'll talk about that in a minute. Then there are network standards defined by IEEE, which are standards for, say, 10G base T, 10 base T, whatever, some sort of a networking standard. Now the cabling and network standards are designed to fit together. These two organizations actually work very, very closely. We have representatives on both of these. So when IEEE wants to think about a new networking standard, they also think about, well, what kind of cabling will we need to support this standard? And so the best way to explain this is to show you this table right here, is to show you the cabling standards. Now, as I mentioned, ISO and TIA generally work pretty close together. The standards I've put here on the same row aren't exactly the same, but they're pretty darn close. And for most people, you really don't need to notice the difference. So for example, Cat5 was pretty much designed to support 10 base T and 100 base TX. You run 10 base T on Cat3, but I don't even know if anybody makes that anymore. Cat5e came along, and it was designed to support 1000 base T, or gigabit Ethernet over twisted pair. That's also ISO Class D. Then you can see Cat6 came along, wasn't popular for a real long time because it was limited to 35 meters on 10G base T. So the standards committees went back, they tweaked things up a little bit, and they came out with 6A, which has pretty much replaced 6 as a technology being installed. And now it allows you to run 10G base T over 100 meters. And then the latest standard that's come out is Category 8, which is called Class 1 or 2 in Europe. And it supports all the way up to 25 and 40G base T, but limited to 30 meters. So it's pretty much right now a data center technology. However, as you can see, the standards can kind of get changed a little bit and then can support different types of networks. Now, let's talk a little bit about that. What's the difference between cabling standards and network standards? And I have an example here that I'll show you about that. So when Category 5E cabling came out, it was right about the time that gigabit Ethernet was being developed, and these things were developed together, and they go together, just like Brad Pitt and Jennifer Aniston, right? You know, back in 2000, they went together. Gigabit Ethernet, Category 5E cabling. It was great. So really, what was the difference? Well, at the time, maybe not that much. But in the last few years, something changed. In 2014, a new standard for Wi-Fi came out, 802.11ac, which you've probably heard about, and it supports Wi-Fi up to 6.7 gigabits per second. Now, to make it work, you need to run 10G base T, right? Because you can't run 6.7 gigabits per second over a 100 megabit connect or 100 gigabit connection. It's going to slow it way down, right? It's only as strong as its weakest link. So if you wanted to deploy 802.11ac, you'd need to deploy 10G base T. I mean, that's really expensive. And what about all this cable I've got? I don't want to change all that. So this group got together, the N-Base-T Alliance, and said, I wonder if there's a way to cram higher speeds onto that existing cabling. And that's exactly what they did. They came up with a new standard where they can cram 2.5 gigabits per second into Cat5e cable, and even 5 gigabit per second into Cat5e cable with some limitations. It'll certainly work on Cat6. So they basically, through clever signaling and electronics and magic and stuff, they managed to make this work. So now you can install N-Base-T or 802.11ac over your Category 5e cabling. And just in the same way that Brad Pitt moved on from Jennifer Aniston to Angelina Jolie, you can move your Cat5e cabling from gigabit Ethernet up to N-Base-T, which is 2.5 gigabit Ethernet, or maybe even 5 gigabit. So I hope this makes it all very clear to everyone why Brad Pitt is like a cabling standard. Angelina Jolie and Jennifer Aniston are more like a network standard. Okay, let's talk a little bit about cabling problems. We did a research exercise a few years ago to find out what the biggest cabling problems were. And we found it kind of amusing because we make a lot of complicated test equipment that helps you figure out all sorts of complex cabling problems. The funny thing was is the biggest problem is cables don't go where they're supposed to. They're not labeled properly, and they don't go where you thought they went. You unplug something and you try to plug it back in and it no longer works because it was labeled wrong. So this is the #1 problem. Now, actually, a lot of our testers can help you with that because they have identifiers that you can plug in, say, into the patch panel or the office, and then go around and plug into the other end and see, well, which one is that? Wait a minute, I thought I plugged number 2 into that jack, but this one says it's number 5. So we can help you troubleshoot that problem, but it is the biggest problem that people have with cabling. Now, what else? Split pairs is another big problem, because a lot of times I hear people talk about, I'm just going to make a straight through cable. Well, when I hear that, it sets off a little alarm bell. A straight through cable really should be what you see in the center here. And notice how the pairing is a little bit strange. This dates back to the old telephone days, and I don't exactly understand the reasoning for this. I'm sure there was a good reason. But the 1 and 2 and 7/8 pairs make a lot of sense. But 3/6 and 4/5 are the other pairs. Now, you might think, well, I'll just run a pair between 1 and 2, a pair between 3 and 4, and that's what happened over there on the right. And what you get is, especially with Ethernet, which uses 3/6, 4/5 pair in lower speed Ethernet, you get a transmit and receive pair twisted together and another transmit and receive pair twisted together, and it will not work. Or, as I mentioned, if the cable's short enough, it'll work intermittently. And so this is a very tough problem to deal with. You really don't want this, and that's why it's important to make sure, if you ever buy a cable tester, make sure it can tell split pairs. The really inexpensive ones that just use DC testing, excuse me, they can't tell the difference between the cable in the middle and the cable on the right, but your network equipment certainly will. Excuse me. Now, another problem, broken cables, right? Stuff pulls out of walls, people run over things with their chairs. All kinds of things can go wrong with a cable. And if it's broken, you want to know where. And that's something we'll talk about when we get to test equipment. Installation. Now, if you go to a Cabling Installation and Maintenance magazine or on Reddit, you can see a parade of cable installation horrors that will stand your hair on end. I just grabbed one picture here. I think there's some fine twisting there. You know, the pairs need to be twisted together, not everything all twisted together, as you see on the top there. Literally, we've had installers tell us about wire nuts. Maybe if you're not an electrician, you don't know what wire nuts are, but wire nuts are what your electrician uses to put connections together, like inside of light sockets and things. It's great for 60 hertz AC, really bad for gigabit Ethernet. It doesn't work. Actually, I heard a story once of wire nuts being used on fiber optic cable. I don't know if that's really true, but it's a pretty good story. So anyway, installation can be a problem. So if you look at the one on the lower left there, you can see there's a good job of installation. The pairs are nicely twisted. If you look at the one on the right, that's not really such a good job. You can see they're untwisted for long distances, a good maybe inch back from the connector. That's a bad installation job. Another thing that can be a problem is components. And this is pretty rare, but it can be a real disaster when it happens. One of the biggest problems we've seen out there in the world is what's called copper-clad aluminum cable. In an effort to save money, there are some manufacturers out there that are making a cable that's not copper, it's aluminum, and then it just has copper around the outside, so it looks like it's copper. But one of the ways to notice the difference between this is the fact that aluminum's a lot lighter than copper. So literally, we have had customers send us boxes where there are metal weights in the bottom of the box to make it as heavy as a copper box. So if you pick it up, you think you got a box of copper cabling, but you don't. And you remember I mentioned some of those other strange measurements like transverse conversion loss. Those can find things like copper-clad aluminum cable. Also, some of the resistance measurements can help you find that. The biggest problem with this is that it has real problems with power over Ethernet, but in general, the quality is not that good in the first place, and you can have all kinds of problems with this. If you buy from a respected manufacturer, you have almost no chance of running into this problem. But if you've got a contractor or somebody who's really cutting corners, be careful, watch out for this. We have a white paper on this topic, by the way. Another problem is patch cords. Patch cords really vary in quality. And the worst is what you see on the right here. You probably know that as a silver satin patch cord, which can be a real nightmare. They're not twisted at all, which I guess is better than a split pair cable, but not a lot better. And these will fail. You also have, of course, the guys who bring these from home to try and fix their network. It's not going to work either. So how do you prevent problems? Well, I recommend three things. First off, use an installer who knows what they're doing. If you are an installer, I hope you know what you're doing. We have actually certification classes for installers. Over 10,000 people have taken those classes around the world. So get somebody who knows what they're doing and who will also make sure they buy the right components. Make sure you're using the right components along the way. If you're using a good brand name, you don't really have much to worry about. And finally, if they certify it and test it, then you'll know for sure that they did a good job. Because as I said, the difference between a cable that works and a cable that doesn't work can be pretty tiny. It can be pretty easy to miss. If you've got a certification report, then you know all your cables are good and you don't really have much to worry about. And you also know that you're future-proofed if some new technology comes down the road, like N-base-T, that you'll be able to handle that. So let's talk a little bit about troubleshooting. Three troubleshooting technologies that are very common and very, very helpful are listed here. The first one is TDR, time domain reflectometry. That allows you to tell the distance to an open or a short and where the problem is. Opens and shorts are probably the most common problems, aside from cablings going to the wrong place. And so with one of these, you can tell where it is. The problem is almost never in the wall, right? It's going to be at the jack, it's going to be at the patch cord, it's going to be at a patch panel. And with one of these testers, you can tell, as in the example here, oh, it's 121 feet away. That must be at the patch panel because it's not in this wall jack here. So it saves you a lot of time when you have to go and troubleshoot where the problem is. Cable identification, I mentioned before, where you can plug an adapter into the far end of the jack and then go plug in your tester and verify that you're connected to the place you thought you were. In here, in the illustration in the center, you can see there's a number 5 next to the far end of the cable, which indicates you're plugged into cable identifier number 5. And if that's the one you thought you were supposed to be plugged into, great. If not, now you know something's wrong. And finally, toning. Toning injects a signal onto the cable that's unbalanced, that makes a lot of noise, electromagnetic noise, and then you can use a probe like the one you see here to actually trace along the length of the cable, and you'll hear the tone. As you get closer to the cable, the tone gets stronger. That's a really powerful tool for troubleshooting, especially very messed up wiring closets. But even in a patch panel, it can help you identify which jack goes where. It's even easier than using the cable identifiers. You can just put the toner in the office, say, and go back to the patch panel and start plugging the probe into the jacks until you see the one where you get the loudest signal. That's the one you're plugged into. So let's talk a little bit about the types of testers that are out there on the market. Well, the first one are what we call verification testers. They provide the basic diagnostics, the stuff I just talked about, TDR, toning, and what was the third one? I forget. TDR, cable identification, and toning. And they run around $500 or so. You can pay a little less, a little bit more, get more features, more identifiers and whatnot. The next level is qualification testers. Now, these actually test against the network standards. And they'll tell you, will this cable support gigabit Ethernet or 100 megabit Ethernet? The verification tools won't do that. They'll tell you you wired it up right and it's connected properly and there's no split pairs, but they won't tell you the difference between say, a cable that could support gigabit or 10 megabit. They also provide the same sort of basic diagnostics that we talked about, and these run about $1,500. At the top of the pile are the certification testers. They test against the cabling standards. And remember that big list of stuff I showed you that you have to measure? They measure all of that stuff and tell you whether or not all of those things pass as per the TIA or ISO limits. They also feature some really advanced diagnostics. To be honest, unless you test a ton of cable, you might not ever run into some of the problems they solve. And they start at around $10,000, so they're definitely a different kind of tool. They're also very, very fast in terms of certifying cable, so if you have to test a lot of cable, they're a good choice. Now, I mentioned the advanced diagnostics. I have something here that I love to show, which is kind of funny because advanced diagnostics, it reminds me of something, if you've ever read about the Tesla cars, they can accelerate very, very fast because they're battery powered, right? And in fact, they have different modes if you want to make them accelerate very fast. And they have this one mode I think they can go from 0 to 60 in approximately 2.5 seconds. I don't know the exact number. And they call that ludicrous mode because I think it discharges the battery so fast that you probably can't drive it more than a few more miles after that point. But I think it may be the fastest accelerating car that you can buy on a showroom. Our DSX series has what I like to call ludicrous diagnostics. Yes, of course it'll find opens and shorts and split pairs and which cable goes where and all that, but it can find some really detailed stuff that I don't even know how I find some of this stuff. So it can not only tell you, say with a crosstalk problem, that there's crosstalk, it can tell you which connector, where the crosstalk is. So if somebody untwisted a little bit too much, we know which connector it's in. Another one is that it can tell if the cable's damaged or if the cable's actually bad quality. So I mentioned like the copper-clad aluminum and all that, it'll tell you exactly which cable and where in the cable. And in this case it says it's not a spot in the cable, it's the whole cable that has a problem here. And a lot of this is because we've worked with tens of thousands of customers who've had problems, and we now know what they look like electronically, and so we can put it into this simple. But this is my favorite. We can actually tell if there's water in the cable because we know now what that looks like. So there's dozens of these kinds of problems, and I gotta admit, you probably never run into water in your cable in your life, unless you install a lot of cables or deal with a lot of cables. But the DSX series, our top-end certifiers, have just ludicrous diagnostics. There's probably no one person in the world anymore who's smarter than what this can find because it's got hundreds of years of experience that we've got with troubleshooting these kinds of problems built into the instrument, and I just find this amusing. Anyway, so what do you want to buy? A certification tool is really what you need if you're testing new installations. If you're building a new building and you're putting in new cabling, I'd recommend you buy a certification tool, or you hire somebody to do it, or you rent one of these tools. They're easy to rent, by the way. They're not hard at all. Also, the test results that you get from a certification tool can be given to a manufacturer, a cabling manufacturer, and they will certify your cabling then for 10, 15, sometimes even 20 years of use, goodness. And the third one is if you don't trust your installer and you want to go around behind them and see what they're really doing, then you need a certification tool. That's what you want. Now, for most people who manage a network who aren't in the cable installation business, a qualification tool is good enough. You can use that to check the existing cabling that you've got. You know, you've moved into a new plant and there's cabling there, but is it really going to work for gigabit Ethernet? You can check that with this product. Also, you can do your troubleshooting and you can do your documenting. It actually can save reports and then you can document them and keep track of your cable plant. And finally, verification. If you just want to do troubleshooting, then that's the tool for you. One other thing I should point out, the certification tools also have the capability of adding fiber optic testing. So if you do a lot of fiber optic testing, I can take one of those certification tools, plug a module into it, turn it into an OTDR, but that's for another class. All right, now I'm going to open it up for questions. Let's see what we got going. Has anybody come to me with any good questions yet? I'm going to see if you can stump me with your cabling questions. Well, one of the first questions I see was, will there be session notes made available or should you take notes? We can make this presentation available. We can send it out to everyone. It's also being recorded, so if you want to share it with your friends, feel free to do that. Okay, let's see if we got any other questions coming in. Gosh, I think I may have covered everything. Nobody seems to be asking me any questions. Oh, so there was a question, can we access the video afterwards? The answer is yes. We'll send everyone a link to the video afterwards. Oh, here's a good question. Should I use TIA 568A or 568B and why? Actually, we have a great blog post on this that we just did. And the difference between 568A and B, in fact, I'm going to go back a few slides if it will let me. Go back a few slides here. The difference between A and B, and I don't know them off the top of my head, I should warn you, is it's which pairs, basically which colored pairs are used together. So this is either A or B, I think. Probably somebody on this phone call is smarter than me and is going to tell me whether this is A or B. The key thing is, so in this example, orange is 1, 2, green is 3.6, blue is 4.5, and brown is 7.8. The other standard, the A standard, I believe, uses a different coloring scheme, but the pairs are all still the same. So the point is, if you use A or B, it doesn't really matter as long as you always use the same on each cable. If you put A on one end and B on the other, you got a good chance of getting split pairs. So just make sure you always go with that. I think A is less common now. I think most people have gone with B. So if you're doing something new, I'd go with B. If you're doing something in an existing plant, figure out what you've got at the other end. And that's a very good question, though. One person said that, yeah, somebody also pointed out we have a poster. I'll get to that in a minute. Another person pointed out that A was more for residential and B was more for commercial. That may well be true, but I know that B is more common for, nowadays at least, in most of the stuff that we see. Okay, so what other questions do we have that I can answer? Questions with return loss. You know, return loss can be a problem based on either installation or the cabling. And so that's probably a good question to take up with our technical assistance center. If you're seeing a specific problem with return loss, they can probably help you answer that and help you understand why you're having those kinds of problems. Let's see. What's a common cause for static on a voice over IP phone with power over Ethernet? Boy, you guys are going to ask some really hard ones here. So that one, I suspect static. It could be a cabling job, and then that's one reason why certification. If the cable's certified, then I suspect it has nothing to do with the cable, because PoE should not interfere on a good cable with the audio signal that you're getting, which is actually a digital signal anyway. So I would suspect it may be something other than the cabling. The only way to exempt the cabling or to understand that it's not the problem would be to probably test it with a high-end tester as opposed a certification tester as opposed to a low-end type tester. There's a very good question. In fact, that brings up one I'll talk about. How would I test a cabling job done by someone else when the cats are Cat 5e, but cable and patch panels are Cat 6? I presume it would only pass with the weaker link. Okay, so here's the deal on that. The standards say that if I build a link that is designed to pass, say, Cat 6, we'll use that as an example, I have to use Cat 6 components. Now, I could build a link that used some Cat 6 and some Cat 5 components. Does that mean it would not pass if I hooked up a tester and tested it? No, actually it might. You can set the link, you can set the tester and say, look, I want you to test this as a Cat 6 link. And you could test it, and it might not actually be officially an all Cat 6 link, but the tester might say, you know what, it passed every test it needed to. It passed all the parameters. Legally, it's not a Cat 6 link, but electrically, it is. So my point to you would be is you could use it, but electrically, it wouldn't be. And obviously, if you ran into some problems down the road and you brought somebody in to look at it, they might go, well, it's your connectors. That's the problem. So that's an interesting thing to think about. But remember, in order to legally make a Cat 6 link, it has to be made of all Cat 6 components. And that's true with any of the standards. Let's see. Well, that's a tough question. I do not know the answer to that one. Do I think local jurisdictions will start making installers carry a license to install ICT with PoE wattages going up in the future? That's possible. It's very hard the way that PoE works to actually make it dangerous. It will only apply power if it sees certain electrical conditions at the far end of the cable, which your body or your tongue cannot provide. And if those conditions go away, the power will shut off. So it's actually very safe. However, there are some worries about cables heating up. And there's a new standard from UL, and now, again, you're going to get me, but if you check out our blog, we just put up an article about that, about this new standard. I believe it's LC cabling that UL is putting out that's basically cabling that's been tested for temperature issues and heating up with PoE and to prevent those kinds of problems. So if you're worried about that, I'd recommend going with that sort of certified cable. Let's see. Somebody here said the IT guy will always blame the cabling. Yeah, that's based on experience. Yes, that's true. A question here is about an RJ49. I'm not familiar with RJ49. That's a new one to me. Another question is, when using an AC router, is it best to use Cat6 cable? How much performance loss is there with Cat5e? So the problem you run into is if your cable's not good enough, you're going to get a lot of errors and retransmissions because that's the way Ethernet works, and it's very good about that, but it kind of masks the problem as well. Cat5e is good in virtually every instance for supporting 2.5 gigabit Ethernet or 25G or 20, what is it? 2.5 G base T, 25 G base T, but or N base T, that version. But it's not always going to be good enough for 5 gig, and it requires extra testing. There's an app note out by the N base T Alliance that we helped write that tells you about the kind of testing that you need to do on Cat5e cables to verify if they will support 5G base T in addition to 2.5 G base T. So if you want to run 2.5 gig on your Cat5e cable, you shouldn't have any problems if it was certified and you know it's Cat5e. But if you want to run the 5 gig, you may have to go in and do a little bit of retesting. The testing that's required is around alien crosstalk. If you have cable in bundles, you not only get crosstalk between the pairs in the jacket, but between adjacent pairs. And there are ways to test for that, and if you have a contractor that knows how to do that, that's the way to check for that. It's a fairly easy test, especially since you only have to test the cables that you want to use for your access points. But that's what I'd recommend that you do there. But I'd go to the N-base-T Alliance website and find their white paper on cabling, and it explains exactly how to do that. Let's see, what else have I got? There's a few good comments that are coming up about, you know, the difference between more expensive and less expensive cable is the headroom, and that's correct. The headroom is the distance, the amount of space, to say, between the amount of crosstalk that's allowed and the amount of crosstalk in the cable. Let's see, one more question here. The difference between outdoors and indoors cabling, UTP in any category, that's more the design of the jacket and the conductors. It doesn't really have any impact on the cabling performance itself, and that's pretty much what I look at. So I don't really know the differences. You'd have to talk to a cabling manufacturer to know the difference between indoor and outdoor cabling. But in terms of that, like I said, it's more about its ruggedness and its rust impermeability and things like that. By the way, the quality of the cable will not let you run it further distances. I went back, I remember I mentioned the skew and delay skew. No matter how good they make the cable, they just run into the physics of how long you can make it. Now, I'm sure somebody now is going to tell me about the 150-meter 10-base T link they ran, and I've seen it done, and it will work, but it's not the standard, and if you ever tried to run anything faster, say, on that link, you're going to run into some real problems. So that's why it's better to stick with the standards. If you want to run something a longer distance, you need to get a repeater or use fiber or something like that. Cheating will work for a while, but you know, your successor, or maybe even you, 5 years from now, might have a real problem on their hands to figure out how to make that link run faster. It won't just be a matter of plugging in some better hardware at each end. Okay. Okay, one more question. If I'm simply changing access points, what is the best way to certify the existing cabling is good? Well, once again, if you're just running gigabit on that, one of our verification testers would be good enough. So let's see, going back to that question. So let's say you're installing a new access point. As long as you're running it up to a gig, a qualification tester like this one here would probably do the job. If you want to run it for anything higher than a gig, you're probably going to need a certification tester because the qualification testers pretty much run out of gas at a gig. So if you're installing an AC access point, you're going to want to use a certification tester. Now, as much as I'd like to tell you if you're a network guy to go buy one, I'd say hire a contractor, have them come in and test it for you. It's a lot cheaper than buying one of these testers. And they can test whatever else you need and help you fix it if it's not going to work, you know. All right. Can I recommend any other basic or introductory videos or webinars? That's probably the last thing. Let me put you to this here. I'm going to skip ahead here. Here are some things that I think would be very, very useful that I think could be kind of handy for you. First off, we've got a great poster that goes through a lot of the stuff I did without all the jokes, and there's no Jennifer Aniston, so I apologize. But you can get a poster that talks about all of the twisted pair cabling measurements at this link. You can also learn about cable testing by going to this website right here. We have a lot of links to various documents and white papers and even a few videos, I think, that'll tell you a little bit more about cable testing. If you're thinking about buying a tester, we've got a copper cable tester selection guide, which is pretty cool because it goes from everything from the the really basic stuff I talked about, the toners and whatnot, $100, couple $100, all the way up to the certification tools. You can compare them all and see what's right for you. And we even have links so you can go and buy them right there. And finally, if you want to stay up on the latest developments, I mentioned this a couple of times, and this is really very useful, I think. That's how I stay up on the latest developments. You'll see we have a Cabling Chronicles blog, and we talk about everything from the basics of cabling, like how does wire mapping work, the difference between 568A and 568B. There's actually an article in there that we recently put up about that, all the way up to what's the latest going on in the standards committees on fiber testing and some of the real high-end stuff that's going on as well. So if you want to keep up on cabling and what's going on, that's a great thing. We have a couple articles a week. We're really lucky that we have a lot of experts around here that can help explain some of this stuff in fairly simple terms. So that's a place I would recommend. So to finish up, we will be sending you a link to this recorded version of this presentation and the slides if you'd like to get them. And with that, I'll just leave this up here on the screen for a few more minutes. So if you want to copy this addresses or take a screenshot. But in the meantime, I'd like to thank you all very much for coming. I hope you got a lot out of it. And we will talk to some of you later, I'm quite sure. Thanks again.